In this video, I'm going to do integration by substitution. The integral is 4x cubed times square root of 1 plus x to the power 4 dx. We are going to use the substitution method to integrate this. But before I do so, let me give you a little bit of background of it. So let's say we have a function f that is continuous on some closed interval, let's call it AB. Then by fundamental theorem of calculus part 1, we know that there is a function which we labeled by uppercase f corresponding to lowercase f, uppercase f of x, with the property that when we take the derivative of uppercase f, derivative of this function, we get the f of x, lowercase f of x. So that means this prime is equal to this. However, let me kind of change things a little bit here. So let's say I have this f of x, and I'm going to look at it as this function taking in as input x. So think of it this way. If you have a function, let's call it g, x goes in as input, right? Input, and it gives you output g of x. What if the input changes to maybe, let's say, h of x? Then the output is going to be g of h of x. This is function composition, you know, right? So right now, this function is taking as input x. So if I were to change the input to something else, let's call it g of x. G of x, okay? The corresponding change in f is going to be f of g of x. So if I were to ask, if I take the derivative of this function, I'm definitely not going to get this, right? So let's say we take the derivative of it. Using the chain rule for derivatives, this is going to be f prime of g of x times g prime of x. Now, according to the definition of antiderivative, these will have antiderivative this, because if I take the integral dx, I'm going to get this guy, f of g of x, with a variation of c, right? That means with an extra arbitrary constant c. This is a family of functions that differ by constants, okay? Now, sometimes what we do, we replace this g of x by, or substitute this g of x by something called u, so that this becomes f of u plus c. So the idea behind this is to consider the function composition of the uppercase f. Now, as it turns out, when we are trying to find integrals, there are situations where our integrals are of this form, okay? If we can find that, then we can just go ahead and do the substitution, okay? Use substitution, and then it will do it. We will be able to find the integral. So this is one such problem. In this case, my u is going to be 1 plus x to the power 4. Then my du over dx is going to be 4x cubed, which I could rewrite as du is equal to 4x cubed dx. Now, this du is the differential change, or very tiny change you can think of, and that is being represented by small change in x multiplied by 4 times x cubed. So these changes together would give you the differential change in u. Now, if I were to kind of rewrite this, what I'm going to get is integral square root of 1 plus x to the power 4 times 4x cubed dx, okay? So I tend to think of this as my du. Now, I can do the following, square root of u, because this is my u, right? And this is my du. So I'm going to have du, right? Which is going to be integral u to the power 1/2 du. Now this is something we can integrate, right? We know that using the power rule, u to the power 1/2 plus 1 divided by 1/2 plus 1 plus some arbitrary constant c. I can call it c1 because I use c here already. So that's going to give me u to the power 3/2 divided by 3/2 plus c1 arbitrary constant, and 2/3 u to the power 3/2 plus c1. Okay, and that, by the way, is going to be equal to 2/3 times u to the power 3/2, which is 1 plus x to the power 3/4 plus some arbitrary constant c. Now, this is how you use substitution to find integral. So here is an example where you use substitution to find integral. And the process is very straightforward. You make the substitution in such a way so that the derivative of the substitution becomes whatever is remaining. In our case, it was 4x cubed dx. So I hope that this discussion was helpful. Thank you very much.